So today is our last day, our last class of new material. Okay, so these are our last new material lectures of the semester. On Thursday, we're going to review / take Quest 5. Okay, and Quest 5 is going to cover classes 27 through 30. 27 through 30. So all the stuff that we're going to be dealing with, algebraic fractions. And then Tuesday of next week, we will have a review class for the final exam. And then the final exam is on the 17th at 10:30 a.m. in this room. That is a Thursday, yeah. Right, because you were going to take it early? Yes. Yeah.
And we'll be able to use our perfect powers table for the...
Yep, you can use perfect powers, you can use the key exponent formulas sheet, you can use a calculator, and you can have one page of notes that you make yourself. Okay, so last class we were dealing with algebraic fractions, adding, subtracting, multiplying, dividing them. So we're going to continue with that today. I was thinking maybe we do a couple together from the activities, and then I'll let you finish the activities up on your own. And we're going to, after these activities, we're going to do lesson 30, which covers solving equations that involve algebraic fractions. All right, so we'll start by we'll do these first 3 together, right? Just to give you a little refresher before. Sorry. Yeah, page 232. Okay, so to review, what has to be true about denominators in order to be able to add fractions? They have to be the same. Okay, so the way we've been setting this up is that we just recopy the problem, but we put a big fraction bar, copy the denominators as they are, and then each denominator looks at the other denominators and wants to have what the other denominators have. Okay. In terms of factors, and the word factor means things that get multiplied, right? So when I look at x minus 2, I have to think of that as an entire factor, right? Because what's separating the x and the minus 2 is subtraction, it's not multiplication. So this was causing a little bit of confusion last class. Why do I give a whole x minus 2 and not just a 2 or something like that? So it's because the word factor means things you multiply by. So x minus 2, the x and the minus 2 can't be separated because they're not factors, right? They're separated by subtraction. So we have to keep them together as a factor. Same with the x plus 3. So it can help whenever you see things grouped like that with addition or subtraction, put them in parentheses so you can treat them as an entire factor. Okay, so this first fraction looks at the second fraction and goes, that fraction has an x plus 3 and I would like one too. So we got to add an x plus 3 to both the bottom and the top of that fraction. Because if you multiply on the top and the bottom of a fraction by the same amount, that's just a fancy form of 1 and you're not actually changing the value of the fraction. And you go to the second fraction, and the second fraction needs an x minus 2. Now I have 2 fractions with the same denominator, so I can add the numerators. Okay. Keep the denominator the same. So my denominator is going to be x plus 3, x minus 2. And my numerator, I'm going to multiply, distribute my 3, and I get 3x plus 9 plus 2x minus 4. Why did I not need to put any parentheses in that numerator's expression? Sometimes I put parentheses and sometimes I don't. It's separated by addition. When they're separated by subtraction, you need to have parentheses because you have to distribute that negative sign. So the next one we'll have to do that, so we'll keep that in mind. All right, so now I just combine like terms in my numerator. So 3x and 2x is 5x. 9 minus 4 is 5. Am I done? Yeah, from the numerator, 5x plus 5 can factor. I could factor out a 5 and I'd be left with x plus 1. Okay. And the reason you factor the numerator, if it's possible, is you've got your fingers crossed that you'll factor it and one of your factors on the top and the bottom will be the same and you can cancel them. That didn't happen in this case, so now we're done. Nothing to cancel. That would be totally fine too. Yeah, if you had left it here, that would be acceptable. Yep. The danger with not doing the factoring is that you might miss a possible cancellation and then your fraction wouldn't be fully simplified.
So stopping there on the far right, that would be if we're unable to cancel it.
Correct. Yep. Yeah, you should always just factor it. Yep. All right, so that one was kind of special because the two denominators had nothing in common, right? So let's see what happens in the next example. Just copy it exactly. Okay. But I'm going to factor each denominator here. So I just copied the numerators and I put big fraction bars. So 8x minus 4, what can I pull out of there? A 4. The GCF of 8 and 4 is a 4. So I'll pull out a 4, and I'm left with 2x minus 1. And then 6x minus 3, I could factor out a 3, and I'm left with 2x minus 1 again. All right, so I think of these things in the denominator. If they're separated by multiplication, they are factors. And it helps if you put parentheses around all of your factors to identify what they are. So the two fractions look at each other. They want whatever the other one has that they don't have. They both already have a 2x minus 1, so I don't have to give either one of them that. But this first fraction has a 4. It needs a 3. So we put a 3 on the bottom and the top. The second fraction already has the 3, but it needs a 4. So I multiply by 4 on the bottom and the top. So now I have a common denominator of 3 times 4 times 2x minus 1. And my numerator is going to be 3x minus 8. 4 times 2 is 8. Now, does 3x minus 8 factor at all? No, 3 and 8 don't have any common factors, so that's as far as we can go. So you can circle it there, or if having 3 times 4 bothers you and you'd rather write it as 12, you can do that too. Either of these answers is totally fine. All right, so that one involved factoring the denominators a little bit. We were just pulling out GCFs from both of the denominators. The next one is going to involve some more complicated factoring. So we'll do one more together, and then I think you'll have seen all the different kinds again, and you can work on some on your own. Okay, so again, copy the numerators with a big fraction bar. And then I'm going to try to factor the denominators. X squared minus 9, how does that factor? Good. It's a difference of perfect squares. X squared is a square, 9 is a perfect square, and those always factor to a plus b, a minus b, right? X minus 3, x plus 3. Didn't really write enough space there. Okay, x squared minus 2x minus 3. Anybody factor it in their heads? Great, you guys are getting good at this. X minus 3, x plus 1. Okay, so the two fractions look at each other and they say, okay, we both have x minus 3s, that's cool, right? But one of them has an x plus 3 and one of them has an x plus 1, and both fractions want to look the same. So this fraction needs an x plus 1. And if you put it on the bottom, you got to put it on the top. This fraction needs an x plus 3. And now I have the same denominator. I have two fractions with the same denominator, so I can just subtract the numerators, put it over my common denominator, x plus 3, x minus 3, x plus 1. Okay, and then I'm going to distribute my 3 here, so I get 3x plus 3. And then I'm subtracting this entire numerator. So I'm subtracting 2 times the quantity x plus 3. So if x were a number, right, this would just be some number that I have to subtract, right? So I have to subtract 2x plus 6. Right, so distribute the 2 and you get 2x plus 6, but you have to subtract all of that. That's one quantity and you got to subtract the whole thing. So then you distribute your negative sign, so you have 3x plus 3. So that's what I was talking about before. Sometimes you write parentheses there. That is typically when you have subtraction. When you're doing subtraction, keep parentheses around that second numerator so you remember to distribute the negative sign. So I've got 3x plus 3 minus 2x minus 6 over x plus 3, x minus 3, x plus 1. 3x minus 2x is x. Positive 3 minus 6 is minus 3. Any common factors in the top and the bottom? X minus 3 appears in both places, so that can cancel. And we'd end up with 1 over x plus 3 times x plus 1. All right, so that was a little review. We already learned how to do this last class. There's lots more for you to practice, and we're going to practice until, let's say, I don't know, we'll see how it goes. At least 10:30, maybe a little longer if you need it. So in this lesson, we're going to solve equations that include algebraic fractions. So we're still going to be doing the same process of finding common denominators. Okay, so you're going to get to continue to practice what you were just practicing, but we're going to go a step further because now we have equal signs, right? Now this is an equation that needs to be solved, so your answer should be like x equals a number instead of an expression. So when you're solving equations, the first step is going to get to have all the fractions to have a common denominator. Okay, so that's where it's the same as what we were doing before. Make all your fractions in the entire equation have the same denominator. Once that's done, multiply both sides of the equation by that common denominator. So you're allowed to do anything you want when you're solving an equation as long as you do the same thing to both sides. So we're going to strategically multiply both sides by the common denominator, because then all the denominators will cancel. And you'll have an equation with no fractions in it, and it will be easy to solve. All right, don't forget, absolutely mandatory to check your answers when you're solving algebraic fractions, because you will sometimes get what's called extraneous solutions. You'll solve and it'll look like there are two solutions, but one of them really doesn't work. All right, so let's do an example. I have 1 over x equals 8 over 6x plus 3. Step 1 is factor all the denominators. Okay, so I have 1 over x can't factor any further. And 8 over 6x plus 3, how do I factor that? It's equals, thank you. Equals 6x plus 3, I can pull out a 3, right? And I'm left with x, 2x plus 1. Okay. Step 2 is complete the denominators, right? Build a common denominator. Okay, so I'm just going to copy these things. 1 over x with some extra space. 8 over 3 times 2x plus 1. A little extra space. First fraction, what is it missing that the second fraction has? Everything, a 3 and a 2x plus 1. So if you put it in the denominator, you got to put it in the numerator. And then the second fraction, what is it missing that the first fraction has? An x. So I put an x in the numerator and the denominator. Okay, so I've built a common denominator. The difference here is that I'm not adding or subtracting these two fractions, right? I am trying to solve this equation. So at this point, I can multiply both sides of that equation by anything I want. That's one of the properties of solving equations. I'm going to multiply both sides by the common denominator. Okay. So I have, this is a little tight. I'm going to multiply my numerators. So I'm going to get 6x plus 3 over x times 3 times 2x plus 1 equals 8x over x times 3 times 2x plus 1. I want to multiply both sides of this equation by the common denominator. So this side, I'm going to multiply by x times 3 times 2x plus 1. It's like all over 1, right? I'm not multiplying by a fancy form of 1. I'm multiplying by the common denominator. And I got to do it on both sides. So this side, I'm going to multiply by x times 3 times 2x plus 1. That's all over 1. So the whole purpose of this step is that now I can cancel. When you do 8x divided by a quantity and then multiplied by that same quantity, the division and the multiplication undo each other, right? So this says 8x divided by the common denominator times the common denominator. That division and multiplication undo each other and they all cancel. Same thing on the left. 6x plus 3 divided by the common denominator times the common denominator. Those things cancel. And then what you're left with to solve is 6x plus 3 equals 8x. How easy is that? Subtract 6x from both sides, so you get 3 equals 2x. And x equals 3 halves. So then we should check. I'll do my check right here. So copy your original equation, 1 over x equals 8 over 6x plus 3. Replace all your x's with 3 halves, or 1.5 if the decimal is easier for you. Okay, so is 1 over 1.5, does that equal 8 over 6 times 1.5 plus 3? So 1 over 1.5, if you type it in your calculator or you're good with doing fractions in your head, that comes out to 2/3. And then 6 times 1.5 would be 9. And 9 plus 3 is 12. 8 over 12. Is 2/3 equal to 8 over 12? Yeah. Okay, so that is definitely a solution. Yes. Yeah. 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 Then I divided both sides by 2. Yeah. Yeah. So that's the basic idea. Build a common denominator, get rid of that common denominator by multiplying both sides by it. Okay. So let's do one more together. So I have 2 plus 4 over x minus 2 equals 8 over x squared minus 2x. First step is going to be to factor all your denominators. So I'm going to have 2 over 1, and I'm going to write these with some nice big lines here. 4 over x minus 2 doesn't factor any further, so I'm just going to leave it like that. And then equals 8 over x squared minus 2x. They both have an x in there. Both terms have an x, so I can factor that out. And I have x minus 2. Now I build my common denominators. The first fraction, 2 over 1, it needs an x minus 2 and an x. The second fraction, what does it need? An x and a 1. Yep. I'm not even going to write the 1 because multiplying by 1 doesn't change the value of anything, but technically we're putting a 1 there. Okay, last fraction, what does it need? A 1, and again, I can write it if I want, but 8 times 1 is still 8. And x times x minus 2 times 1 is still x times x minus 2. All right, so I've built my common denominator. Now my next step is to get rid of my common denominators. I want to multiply both sides of this equation by the common denominator. So just in the interest of saving space, I'm putting parentheses around the entire equation, and I'm going to multiply the entire equation by x times x minus 2 over 1. Right, so we have to multiply every single term on both sides by x times x minus 2. Think of it as distributing that common denominator to the parentheses. And all my denominators are going to cancel. So I'm just going to be left with 2 times x minus 2 plus 4x equals 8. So you build the common denominator, you get rid of the common denominator. All you're left with are the numerators. Now I have to solve this equation for x. So I'm going to 2 times x is 2x times x minus 2 plus 4x equals 8. Distribute that 2x and I get 2x squared minus 4x plus 4x equals 8. What's negative 4x plus 4x? 0, so that just goes away, right? So I have 2x squared equals 8. Divide by 2, so I get x squared equals 4. How do you finish that? Square root both sides. Square root, so you get x is plus or minus 2. All right, mandatory, we have to go back and check, especially when you get 2 answers. One of them may not actually be a solution. So I got to take my 2 and my negative 2 and plug them into my original equation. Make sure that the equation is true. So I'm going to check my negative 2. So I'm just going to replace all the x's in the original equation with a negative 2. Oops. So I have 2 plus 4 over negative 2 minus 2. Does that equal 8 over negative 2 squared minus 2 times negative 2? So this is 2 plus negative 2 minus 2 is negative 4. 4 over negative 4 is negative 1. Okay, does that equal 8 over, what's negative 2 squared? 4. Okay, so this is 4. Negative 2 times negative 2 is positive 4. What's 2 plus negative 1? 1. This is 8 over 8. Is that true? Yes. Okay, so the equation is in fact true if you replace the x with a negative 2. That means negative 2 is a solution. We got to check. We can't know until we plug it in. Yep. Sometimes both will actually be a solution. Sometimes neither will be. Sometimes only one will be. So you have to check them both. So now I'm going to put in a 2. Right, so I have 2 plus 4 over 2 minus 2. Does that equal 8 over 2 squared minus 2 times 2? So this is 2 plus 4 over 2 minus 2 is 0. 8 over 2 squared is 4, minus 4 is 0. Is that equation true? It actually is nonsense, right? You can't divide by 0, right? So this it cannot be true. Can't divide by 0, right? So x equals 2 is not a solution. So the only solution is x equals 2. So when you solve and you end up with x equals plus or minus 2, the solution that's not true, the 2, we call that an extraneous solution. Extraneous, the key word being extra, right? You produced an extra solution. Okay, try some. I'll leave this up so you can look at it.